So let's get started. The first thing that you need to know are some properties, and this is what you're going to have to write down because I'm going to write down a bunch of them, of equality. So in an algebra problem, we're going to say the left-hand side of an equation will always equal the right-hand side of an equation, and so we want to talk about that. So if I say A plus C is equal to B plus C, right? Then A is equal to B. We'll call that the addition property. All right, let's do another one. It's a similar thing. If I say A minus C is equal to B minus C, well then we could say again that A is equal to B, and that's the same type of property, but this one we'll call the subtraction property of equality. We could do another one if you guys would like. Oh, please, Mr. Adams. Let's do another problem. So A times C should be equal to B times C if and only if A, again, is equal to B. That's the multiplication. Okay. What do you think the next one would be?
Division.
Yeah, you're probably right about that. So the next one would be, let's do. I have to do one thing though. I have to define something. So if I say A divided by C is equal to A divided by, or I'm sorry, B divided by C, then we would say that A is again equal to B, but we also have to kind of point out that A cannot, or C cannot equal 0, right? If C equals 0, then that whole thing's not true. And so you guys were correct in guessing that this is the division property of equality. Then there's some other ones. A equals A is a reflexive property. I think I misspelled that. Yeah, there's no S in that. Why did I write that down? Yes?
Why can't C be 0? Because you can't divide it.
Because you can't have a 0 in the denominator. Does that make sense?
Oh, yeah. Okay.
All right, so now here's another one. If A is equal to B, well then B is equal to A. That one seems rather simple, but we would call this a symmetric property. Of equality. And then this one might look familiar. If A is equal to B and B is equal to C, then we can assume that A is equal to C, right? So that's kind of like cutting out the middleman, right? That's like a syllogism. And that property we would call transitive. And then the last one that we would use, hey, if A equals B, then I could just substitute B in for any A, right? So like if I said 2 plus A would be the same as 2 plus B. And so that one we would just call the substitution property. Why am I not spelling words correctly today? Substitution. Yeah, I guess that's true. Alright. Now, we're going to solve an equation which hopefully all of you guys know how to do because you guys mastered Algebra 1 last year.
Oh, yeah.
Oh, stop. No comments. But we're gonna apply these properties, which proves that the left-hand side is always equal to the right-hand side. So when we teach algebra, could you imagine if we went through all these properties and said, which property would you use? We use little short phrases like whatever you do to the left-hand side of the equation, you do to the right. We say if you're adding, then you do the opposite, which is subtract, all that stuff. But we use all those things. Okay, so we're going to use all these properties as we solve some equations. So how these properties of equality are used in an example problem, I'll show you in a second. So example number 1, we have a drawing of a straight line, and we're told that this angle, 2x plus 30, and x is in degrees here, so we have 2x plus 30 here. This point here is A, this point here is O, this point here is M, and this point here is C. And so we're going to solve for x. Okay? We're going to solve for x, and then we're going to find the angles too. Well, what do we know? How would you guys approach that? What is it? There's something up there that we should know. Yes.
That is a linear pair.
Yeah. So we would say that that's a linear pair, and another way to write that. So we would say I'm going to write it a little different. I'm going to say that AOC plus the angle, or AOM. I'm sorry, AOM plus MOC. If it's a linear pair, what should those two angles add up to?
180.
180, right? So I said they're a linear pair, and earlier we said that a linear pair always adds up to 180. All right? By the way, when I write it up that way, what does that tell you about the two angles? Well, it tells me the angle AOM and angle MOC are supplementary angles. Right? So keep that in mind. What does that mean? Supplementary means that they add up to 180. So a linear pair by default, because they add up to 180, because they share a line, and a line, the measure of a line is 180. A linear pair will always add up to 180, and therefore the linear pair the two angles of a linear pair are always supplementary angles. So now I've got to solve this. Well, first thing I'm going to do is, let's look at this. What is the measure, and I don't have a number yet, but what is the measure of AOC? Well, I don't know. It's 2x plus 30, right? And then what is the measure for MOC?
X.
Well, it's just x. So if I write 2x plus 30 plus x equals 180, what substitute, or I was going to say what property did I just use, and what did I slip and say? I said what substitution did we use? What I meant to say is what property did we use? What was it?
Substitution.
Substitution, right? Since this is equal to this, then I can substitute that in here. Since this is equal to this, then I could substitute this in here. So over to the side, we're going to say substitution. That's a property that I could use.
But you have to write angle AOM right there. 2x plus 30.
You have
The rest
AOC.
The red that you wrote right under the
Oh, I wrote AOC. Oh, I see what you're saying. Good catch. That is very important. Mr. Adams was in a hurry. Technically, it's AOM. Very good. Yes, correct. Sorry. MIUI, she was confused, huh? All right. Sorry about that. All right. Any questions so far? No. Now you guys know how to do this. We did this in chapter 1, right? So now we've got to focus on the properties. So now what can I do here? What would you guys normally do?
Put the x's together.
Put the x's together. Now technically, I could rewrite this and I could say 2x plus x plus 30 is equal to 180. Now what allows me to do that? What property allows me to do that? Well, let's see. When I rearrange the order of things, boy, that isn't one of these properties of equality, is it? Huh?
No.
No, but it is a property of algebra. What did I do there? When I rearranged the order?
You separated.
You guys don't remember, but I'll remind you, that's a commutative property.
Do we have to use that?
The commutative property, right? Now what happens here with the x's though? Can I factor out an x like this and say 2 plus 1 plus 30 equals 180? Can I do that?
Mm-hmm.
Yeah. What property is that I just used?
Distributive.
Distributive property, very good.
Yeah.
So I'm going to say distributive property. In reverse, but distributive property nonetheless. So now what's 2 plus 1? 3.
4.
So I'm going to, 37. So then I'm going to redistribute this. Right, or rewrite it, I should say, as 3x Now what do I do with the 30?
Subtract.
You subtract it from 80.
Subtract it from both sides, and when I do that, I get 3x
So eloquently
is
said.
equal to 150, and then what do I do?
Then you divide both sides by 3.
Oh, you know what I forgot though? Like, when I subtracted the 30 from both sides, like this, what property was that? Subtraction,
Oh, yeah.
right? And then when I divide both sides by 3,
That's division. Property.
that's the property of division, right? And so then I get x is equal to what? 50.
Elena, you were right. Yeah, I know.